So, hello everyone, welcome back. After a long session about observability last month, we're diving into blockchain and web3 today, and not everything else which I keep saying wrong. Yeah, and it's my pleasure that Niclas agreed or said that he wants to share his expertise with us today. And I'm not sure if it's ready yet, but I can keep talking. I'm looking forward to learn something new today. We could potentially do a short round of introductions if anyone is up to it. Or if Niclas is ready, we can also jump into action.
We can do both. So I'm ready mostly. I need only to close some windows, but we can also start. It's like I'm open for everything.
Go ahead.
So. Yeah, okay. So as the title said, we want to talk a little bit today about blockchain and Web3. So first of all, this is like only my personal opinion on that. I'm working in a company who's also doing some blockchain related stuff, but this is another topic. I will show you today a little bit what it can be, and mostly not what you probably know, but more people are familiar with. So I won't talk today about Bitcoin. I won't talk about NFTs. I won't talk about any other, what you probably know as crypto coins like Dogecoin and so on. I'm more interested in the hyperspace, so in terms of distributed ledger technology. So there, and what you can understand under DLT is we have different types of DLTs. So I will also switch right now into my Kurumiro board that I have prepared a little bit. And then we can give me a second. And then we will draw a little bit. Okay. And I need to switch my display in the meantime, but besides that, I can talk to you. Yeah, and this is mostly what we're gonna do today. So by the end, so I want to explain you a little bit the concepts of the blockchain. I want to explain you a little bit how blockchains look like. And in the end, we're doing our favorite parts and everyone can contribute. We will do probably C, Rust, and blockchain technology together. And Node.js, of course, because Node.js needs to be everywhere. So it's like most important. And this is also related to the Web3. So
can we do COBOL as well?
No, we can do also, we could also programming the contract also in C++, but I'm not so good in C++. I'm only a Rust expert by copying code from Rust to another file in Rust. So that's my skill.
But Michael can do that, right? C++.
Yeah, that's you. That's not me. Let's follow Niclas, and then we have the crazy ideas in the end and extend the session.
Yeah, okay. So today, I'm looking for this picture. That's the right one. So today, and I copy it to my mirror, but I'm stealing. I'm seeing it right now. So what we are generally talking about is, like I said, so there are a lot of blockchain stuff going around. So, and I'm not a fan of talking only about blockchain and this is all the source of truth and it will fix all our problems, mostly not, but probably some parts of problems. And mostly what I want to show you in first off is like, yeah, you know, in probably the concept of blockchain, we are living here, but all the topics are in an own space and it's called distributed ledger technology in the end. So DLTs are existing now since 1996. There's a cool article from the first blockchain was in the New York Times. So I will send out later the link to it. I'm already prepared, but I didn't have time. And now we're talking about, when I'm talking about DLTs, there are different concepts of DLTs. So of course you can do have a blockchain. So it means like we have multiple transactions are covered into one block and the next block will be appended. So this is a blockchain. So you know probably some famous designs. So Bitcoin, the fork of Bitcoin with Ethereum. Now there are a lot of more out of it. So that's the reason why we have dots, but there are also different concepts. So it doesn't need to be that blocks chain together. So there are also distributed ledgers that using directly archived graphs, DEX, and of course transaction graphs. And there are also some other big platforms that you know, probably Nano, IOTA, and all the stuff. So what is the main benefit of when using a DLT? So you have increased security in terms of what you're doing. So it's more like we have a problem currently, we are in a digital world, and we want to really ensure that we can trust the people. And for this, we need to have cryptography for that. So because we want to sign something. In the real world, you have a paper and you write something on a paper. So that's it. And you can see from the signing. In the digital world, it's not possible. So in the digital world, you need to have some algorithms or some math skills in the end to really make the ownership of a file to you, that we can see, okay, who is the owner of that file? And probably some of you know this. So we have private key pairs for that, or public key pairs in the end, with a public key and a private key. And this is what we also calling in the crypto world or in the distributed ledger technology, a wallet. A wallet is nothing else than a public and a private key pair. And of course, we now have the signing, we can send transactions. Most of them are for payments, for tokens, but also there are different other types of transactions that can be done. Performance, level of anonymity are different outputs of that, but this is in the scale the DLT. So, and this is quite really good. One of the DLTs that I want to show you today is mostly, probably you're not so familiar with it right yet. So there's a new tool, it's called Zolana. So Zolana is a quite different blockchain. It's also like it's coming from, I need to open it on the page. Cool. You can also see the current transactions. You can see the transactions per second. This is interesting for the pricing and so on. But Solana is a little bit different in all the stuff to Bitcoin and Ethereum because they're using a different consensus algorithm. So probably every one of you is saying, yeah, we're using Bitcoin, but Bitcoin has this type of proof of work. So proof of work is like, hey, I got paid for something. I'm stealing now. Is it in macro? Where is it? Cool. But why it's in German? So why everything is not in German? I need to switch to English.
It's okay. I can read it.
Yeah, but not everyone. We want to be inclusive. Okay.
So how did we land in Solana with the proof of work now?
Yeah, I will cover it. So coming back to the topic. So you know proof of work probably, and you know Bitcoin in the case. And everyone says it uses so much energy because, yeah, of course, how a transaction or a new block is created in Bitcoin is, hey, we have mining capacity. Someone of the nodes is calculating a big complex math that needs a lot of power and energy because you do using graphic cards for thinking. Afterwards, a new block is created and many transactions can go in there. So at least a fixed size. And then the new block will be created. But this is, as you would know, is like not easy to do. It's like also not energetic. And this is the reason why people thinking about, okay, there needs to be like other, when we can have a distributed system and need to trust each other who can create the next block into our chain, because a blockchain is like you're starting from the beginning, the first block, and it needs to be like a sequence of blocks in the end. So you have multiples. And for this, there's a new type of consensus, and this we call it proof of stake. The interesting why it's different and why it's probably better in some parts of proof of work is, so here we're saying every node who's in our current system has the ability to create a new block, but the owner with the most coins in the network as a node can create this block. So, and this is quite, you don't need to do magical cryptographic, or you don't need to do any maths for that. You don't need to do any other special types of that. It's only you need to have a lot of coins. to still that. And when you have created a new block as a validator, what's a server in the end, nothing else, you get a reward for that. So you get a little bit transaction fees for every transaction that you do on the chain. And this is like the benefit. So we don't need to have computing power, a lot of computing resources. The system can be still decentralized, and we have a lot of faster, more transactions. So why you're probably thinking about why a transaction is important, there are different systems with transactions. So probably most familiar or most system that everyone knows is the Visa card system. And this system has 24,000 transactions per second. This is the fastest transaction system in the world. And all these chain events for transaction handling are trying to tape this, but for trying to make it obvious that we can use another system of this. So Bitcoin has a transaction per second by 1 or 2. This is the reason why a lot of people now more going into the space. We're talking about here second layer chains and all this stuff, but this is like another topic. Also by itself. Are we having like transaction where the consensus who can create a new block is a little bit lightweight and more proven in terms of that we don't need to use so many proof of, not so many resources. That's the reason why we have proof of stake. And Zolana is one of them. So there are also a lot of probably people can shout out in the chat and all the stuff. In the end, there are multiple chains. By day, they are also putting up some new of that. It's also not what we also can see if you're thinking about Ethereum. So Ethereum will also move to proof of stake in the end. So that it will be also more energy efficient, but it will take time. So we're thinking here about the next 6 to 12 months. So hopefully there are also some research. And as you see, these are currently on the site on Solana. These are live data. So, and this is quite fast. So 2,000 transactions per second is quite good.
So for me to understand, Solana is basically a platform providing access to a blockchain.
Zolana is the platform. So you can set up your own Zolana in the end. So give me a second. Let's go into the Explorer. So you have, when we are thinking about it, you have...
Or is it like a distribution of a specific blockchain or something like that?
It's a special distribution of a blockchain, in simple words. That's correct. So you can see currently here, I'm switching now a little bit. So here we have the latest block, for example, on Ethereum. This is also a familiar blockchain. And we have the same like for Solana, where we also can see on the mainnet when the latest transaction has happening. And you see also the transaction patterns. You see it's live updating. It's really on the live system on Solana. And we can check what is now the benefit of the DLT is. Yeah, we want really to check if some transaction happened or on some accounts. And now when we had now an ID of a transaction, we could look, okay, who has issued it from which block? And this is the interesting side. So we see here that's a transaction in the end. The result, it was not processed in the end. We see from who it comes. And we see also this is like a little bit more interesting because it's coming from a program. Because we're talking here now about, so typically what you can do on a blockchain is like, give me a second, and can I move the panel to another side because it's like making me nervous.
Yeah. So when you're talking about transactions, what is that? How can I create my own transaction? Because I'm trying to follow your thought process.
Okay. So we have Alice and we have Bob. Right? Quite simple, 2 persons. And now we want to see how the flow from Alice is sending Bob. Can I not make it a little bit bigger? Cool. And I need a text field.
So Alice wants to send something to Bob.
Yeah, want to send some transaction. So he wants to spend some money on that. So in terms of, I don't know why my mirror is a little bit broken in the end. But let me try to refresh. Hopefully that fixes it. Reloading problem. Ah, cool. There we go. That's not. So wants to send some transaction. So I want to send him something, some information. I want to send him a really one Solana token in the end to Bob. So and then Bob has currently would have like then also one Sol, and Alice has now instead of 3, Alice will have in the end a corrected value with 2 Sol. So this is like the concept of after the transaction is done. So and mostly now the interesting how we can signing a transaction. How can I know that it's coming from Alice, or how do I identify them? And for this, we're having something like, we have in Zolana the same like in every country, like on every chain, we have crypto primitives to do a digital signature. So in the end, this means like we have like the address from Bob with an ending B. It's a crypto address. And this is like the address from Alice, where we have.
So it's something like the IBAN system European banks are using.
No, it's not. Yeah, it's like you can think like of an IBAN, but what is behind this idea is right because we are in a digital world, we need to sign something. And how is signing working? You need to have a key pair on that. So you encrypt some information. So we would encrypt the information with the
public key.
With the public key, and or Bob will have a public key from Alice. Oh, I called it Alex. No. This is the public key of Alice, and I have the public key of also from Bob. And these can be used to verify digitally how a transaction is flowing. And this is what all the stuff is happening on a blockchain. So everything what you can see on a blockchain, these numbers are literally public keys. So, and they're using special cryptographs. So this is like a little bit more now going into the details here. So I have a I have a smaller example on that. So this is like a typical byte representation of a public key in Solana. This is also what it would look like in every other crypto system. And what Solana is using, they're using ED25519 as elliptic curves for the signature suite. So you probably know it from your Git also, but there are also some other different key types. So when you probably by people know, the more familiar that people know is probably they knowing RSA.
Yeah, but this is considered insecure, at least if you're not using 256 bits or something.
Yeah, the benefit of the ED255 curve is mostly that we can put more information with less effort in there. So, and that's the really cool point on that. So, for example, you have a key on the values are not the correct ones, but I think so. We're starting with 256-bit ED255 key, and for RSA you would need like 7,000 bits to save it. And this is the problem why you want to use smaller keys. They're a little bit more compact. They can be also easier converted by mobile systems. For example, your phone, it's not so CPU heavy instead of securing the same information.
I do remember when you are using TLS with RSA, one could use the private CA key pair in TCP dump to open the package or packets. Yeah. And with elliptic curve, that's not possible because the crypto algorithm is somehow different or something.
Yeah, the problem of the ED is like how you can hack crypto, or mostly how a public key can be exposed. The trick behind it is like you need to do the same math calculation. And in the end, what we have mostly in all the elliptic curves, or what should be solved, is like we have something like, oh, I made it other way. So that way, A. And I need to have a B.
And make it a little bit bigger because it's super hard to read.
Give me 1 second. I need.
And we also don't need to dive into like the differences between the algorithms. I was just curious.
No, I want only, but I want to explain why it's so efficient and why it's so interesting when talking about that. So A is currently our public key, and no, sorry, A is our private key, B is our public key, and you can do, the problem is mostly why you want to have cryptos, and we call in crypto it's like a trapdoor, that the other way around. So when you cannot easily calculate the private key. So for that, you need to have a lot of compute power. So this is like what's going on. Okay, B is quite easy to calculate. You get the public key, it's quite easy. You don't need to have many compute resources, but getting from A again from B is quite hard. And this is the reason why our cryptos are secure. Because you need to have like prime numbers. So the typical RSA is based only on prime numbers. So elliptic curves using like a mathematically elliptic curve, and then the donation is like you need to want to connect points, and the steps you're doing is your secret key and so on. This is like how the public and private key is working. So nothing special in the end. So and now
and the blockchain needs to be efficient. So like the elliptic curve uses less compute power, and therefore it's faster.
Yeah, of course it's getting faster. In general, all chains are getting faster, and it's secure because then we can really trust the people. Because when you lose your private key, all your information are also gone, and you cannot send other people with the private key. When you lose the private key, you cannot use the same public key then anymore. You need to get a new one. And then this is the reason why you need to protect your private key.
And that's the reason why when I'm using my Bitcoin wallet and kind of losing the private key, everything else is gone as well.
Yeah. So, and the interesting topic about that is like, do I have it here? No. Here. There are some, but this is like an own topic. I can talk the whole day about it. It's like that how you generate the private key is also a little bit different in the systems. So you use for blockchain, you're using like a mnemonic. These can consist of 12 or 25 words in plain English words, and this will be used to generate the private key in the end. And when this is the reason why you can also use like a paper wallet. You can write these words on a paper, put it into your vault, in your local real world vault, and secure in it. And then you can every time generate your private key again. But there are a lot of more advanced concepts of how you can generate from these master private keys and also new private keys and so on. But this is now out of scope. This is like currently not some information. But I want now to jump more into the technical part, because we're going now into 30 we are already on 30 minutes, and I want to show also some, as I explained, some Rust and also some all the other stuff. And then we're looking also how to generate an account and so on. Yeah, okay. So luckily, what I will do now is I have the, we will play a little bit with the Hello World from Zolana directly. So it's a simple hello world, how I can send a transaction on Solana, how I can get a hello back from an account. So account is a little bit special. I will explain it also in the word when we're tackling this. So but let's do first steps. If you want to try it, it's also possible to do in Gitpod. I didn't test it on Gitpod, but it works for sure. So you can also use it. You need to have Rust, npm installed, Solana. I'm running with the latest version and so on, and we can have a look on that. So, okay. So I will first, we can first start our own chain in terms of, because we want to run testing it and using it in the end. So for that, that's really cool on Solana. Make that. So now I will start a program. It's called Solana Test Validator. And what it does technically, it started my own single blockchain on my computer. So it's a one node blockchain where I can do all the transactions and all the stuff and connecting with my account and doing this stuff. So, and you see also, as I said, I'm talking about identities. Everything in the blockchain or on Solana has like an identity. So also the node by itself has an own private key pair to sign the transactions and so on when it doing that. Yeah, so for that, now we need to generate a public key. First of all, we need to connect to our chain. By default, Solana is connected to the dev network, but we want to use ours. So for that, we can use Solana config. It will be connected. And also now we can see that I can expose so now I want to get my personal Solana key that I use for all my transactions, of course, but this is not my real one, what I use on the mainnet. This is for my testing. And you see this is the current ID. So this is the public key. And I would recommend use only save them and use them later. Don't expose them. Under ID JSON, you will find the private key of it. So it uses, as I said, it's quite easy to generate the public key out of it. And it's written in form. So that's cool. So now let's do the next step and let's connect to our chain because we want to inspect also when transactions are happening. And this is really cool. This is what I like. You can go to explore.solana.com, set up a custom RPC URL because it's a browser app, and then it will connect to your current blockchain. So it will connect to Solana in the end. I hope so that it works. Most of it worked.
Yeah, the Gitpod example doesn't work. There is something wrong with the path. Just tried it.
Okay. Yeah, we probably can have, as you see, our transactions on our chain are not so fast on our local chain. We have 2 transactions per second, not 2,000. It's currently running. We have the information when it was started. We can see the current block height. So that means like what is the current block available? What is the next block? So where the next transaction goes in and so on. So, but now we want to do like a little bit hello world. And as you probably know, we're talking about NFTs and coins and all the stuff. And as I have an example, before that, I hate every time when I use Zolana. So we have here Alice and Bob. That's fine. But a smart contract or give me one second. So, but there's also a third option that I can send a transaction from Alice, from my account, directly to a robot. And the robot can be like a function that says only hello, Alice, for example. And this robot, what we are calling now, is like a smart contract. So you probably know smart contracts for NFTs is nothing different. They're more specialized smart contracts, but we will write now our own smart contract for the Solana chain in the end. So the main goal is that our smart contract is doing like hello Alice and do like an increment of 1 every time we're calling it. So when he's identifying us and he sees us, he will increment and greets us 2 times, 3 times, and so on. Yeah, and this is like what everyone uses in the chain, what is so interesting. So there are little different use cases to use these smart contracts, because it's not that they are written by humans, but they are not controlled. So there's no human who's sitting behind it and checking who should I read. So everything is automatically done in the end. And for that, we can write a lot of more advanced concepts like decentralized financing, Uniswaps, general swapping, all the stuff is coming up. Yeah, so, and for that, we will start to deploy our own first smart contract, checking it, and I will see also you, I will show you a little bit the benefits out of that. So, okay, so as I said, we're going into the Solana world right now, and we have different types. So first of all, how can I write my robot? So the robot can be written in different technologies. So it's quite easy. You can use Rust, you can use C, or we can use C++. This is the reason how Solana allows us to write the smart contract in the program in the end. So I would propose to do it with Rust because I'm a little bit familiar with it. C is also fine, but I didn't test it. But yeah. So for that, we have here the program. And we will now make a short look how it looks like. So in the end, a Solana program is like an automation transaction handler, nothing else. So you can do different types. So what we are doing in our example is we will greet every time we see an identified account. An account in Solana is like the for the program is like the identifier. So because the robot needs to remember who is Alice and who is Bob. So the program, our greeter will remember on Alice the ID and also the Bob ID in the end. So, and for this it's been used to getting the information. So yeah, on that we have then everything mostly up, and now we can start to deploy our we will build now our program and deploying it. So what it does, and this is interesting on Solana, so it uses, you can use different languages in the end. You can use, as I said, Rust, C++, and so on. But what's also interesting, only the program needs to be so for BPF, Berkeley Packet Filter. You know it probably from networking in Kubernetes. Also, this concept is used to making the transactions a little bit faster and more secure, and so that you can intercept requests on a chain. So that's the reason why we're having here BPF filters also. I hope so. It's building now. And then let's check. Okay.
I think I found the error in the Git code thing.
I made a pull request. They are happy about that. Cool.
Yeah, just for context, the Git pod workspace is using pre-builds, and pre-builds doesn't evaluate the paths again, so it cannot find the binaries.
Ah. Okay.
I've seen that before, but it could also be a Git bot problem.
Yeah.
Let's
So
continue
as we see now that the file is now done. So, and also what is interesting, as I talked about it, so our program has also an identity. So this is like the public key of our program, so that we need to know where we need to talk to, and we can also check it. So with checking the public key, and we see currently this is the public key where we need to talk later with web3 or with a JavaScript primary in the end to the account that we can get in greeted. So in the end, we have now and shared object. So when we're looking into that with this, I don't have LED because I'm have a Mac. That's sad. Okay, then I probably cannot show it to you directly.
What are you
so
looking
this like
for?
LDD. So checking which the bindings of the library. And so on.
I think it's NM on the file. Maybe not.
It doesn't have symbols in. Okay, we're getting now the object here, and now we need to do a transaction on the chain so that the program is activated. So for that, we can simply deploying it. So, and the cool part on Solana is mostly that it also brings all the development experience. So we can easily say now, Solana deploy, program deploy the hello world. And what it does, it's starting now a transaction because also a transaction is needed. And now let me check what's happening now. Perfect route. Deploying fed. Give me a second. I make a trick. Go start a fresh node. Okay, let's start from fresh again. And let's deploy the program again. Cool. And now when we see, as you see, we get now a program ID, and this is the address where we can speak to the program in the end. And as you see, the program ID is the same ID of a public key. So the public key from the program is the program ID. So every address, it's like in a blockchain or in a DLT, mostly it's like the public key. So, and this is the address where we can speak to. Now, because I'm talking about, okay, how we can speak now for that is like, yeah, we need to have a program also to program it because it's living on a chain. We don't have it. So, and for that, what most people are talking about when they're talking about Web3 is now establishing a connection to the chain, then doing some transaction on that, and probably saying hello world. And that's it. So this is like the whole Web3 thing in a simple word. So of course, people think, no, you can build building more decentralized apps on that. But the more original is like, we can do like simple gRPC calls to the chain and instruct them, sending a new transaction, calling a program, calling a smart contract, doing all the stuff can be done. And for that, we need only to have an open gRPC connection in the end with a fixed instruction set, of course. It's not like that you can speak now every command of that, but the framework who's abstracting this is mostly called Web3.js. And this is what they mostly firm it. So when we are looking into that, it's so we could also do it via JSON RPC, or next time we do it also via the REST API, but I think JavaScript is fine for us right now. And we want now to read our own key. So we have our private key here. And to check something first. Where was it? So pair here. Okay. So, and what we can go a little bit to the program. So we have a pair. So because someone needs to spend money, so because data is expensive on blockchains and you don't want to waste, and this means like every data that is held on Solana in the program needs to be paid a fee. So you need to rent the data space. And for that, we need to have a payer, and the payer account is currently my private account. So the private account that lives currently under the Solana, and it will use this account to getting the transaction fees so that the accounts can be remembered. The program in the example is then creating a small account. The seed for generating the account or generating the public key is mostly like here, hello. Later we can also change it, and I can show you the example of how to run it. And now, for example, when I want to read the first the hello account 10 times, I can now start a simple for run. And we see now here, let's say it will be connected, it's connecting to the chain. We see also how many free fees are over. It shows us the program that is used, and it shows who has been greeted. And currently, now this is coming to the interesting because I thought chains are visible and you can see all transactions. We can look now in the browser for this special ID. This is our program account, and we can see now all the transactions that are also happened. So, and it will show us more and show us more. So because we're doing 10 times, and we can check also the result. So, and we can see what's happening in the end. So we see, okay, it has happened a transaction, it was paid, it was written to the contract. And yeah, and we see also here, it's true because the program has also some program log. We see also how often it was crawled. So we can here also see how often it's greeted, also in the chain. This is quite cool. So because you will probably see, okay, yeah, I talked now to hello 10 times. So, but what would happen in the end? We do it now. We want to read now. Everyone can contribute. And as I said, we need to have an identification. A new key will be created, and hopefully, when everything goes right, we will have now the greeting. We'll start from 1 again. Of course, because it's a new account. So, and we have a new signing key. It will be used for that. And we can now check again the transactions. I need to check for program. Is it that? Here, sorry. And you see now, you also see that the transaction from before was at 500. The chain also mines, the validator mines new blocks again. So it's like now we can check here, for example, that the account GFX, what's currently probably our account with the everyone can contribute, has executed 10 times the transaction to the program. And we can also see currently he doesn't have any tokens. He has a little bit balance. So that means like he has currently a little bit stuff that he could spend on, but probably mostly not enough for the data. And we can see also the data that's currently allocated. So, and for that now, we can build up complex systems. And yeah, so we could there's a lot of cool resources on that. Is there a cruel one?
Could you maybe summarize what you showed us in the past minutes?
Okay. So what I showed you in the past minutes. So first we started our own chain with the Solana test validator. So starting our own chain for local development. We're not forced to use it. We configured our CLI to connect to that. So this was done via this stuff. We having generated our private key pair. I have already created it. You can create it also with key.gen.u, but it will say currently, hey, don't use it because I have already a key. So, and then we have started to deploy first the program. So who's allowing to greeting us all the time? This was deployed after we built it. So we built it with a simple Rust wrapper, and then we started to deploy it again. So we deploy it, and then we started to use it. And we use it with JavaScript in this time, but we can use also different languages. So here we can see this is the whole script for that. So we established a connection to the blockchain. So you see it's also an RPC URL. And then we can have like a framework, because it's wrapped in the web3.js from Zolana, we can execute then different actions. For example, get the current latest block. What is the minimum for the transaction, and so on. Yeah, and now we have like a small example hello world, how to interact with a program, a smart contract on Solana. We can greeting people, we can generate our crypto keys for that. And also we have like a little bit more checking on that. But we're sending real transaction on that. And you can do also the same on the public net. But the problem with the public mainnet is like you need to have Solana on that. And Solana is currently the price, I would think, about $150. So this is like a little bit paid to on the mainnet. But as I said, no worries. So you can also go to the devnet or testnet. There you can generate Solana tokens for free. Or you start locally, because I really like to work locally and can test different things out, programming differently. And the main benefit for Solana, for example, for me and getting started into blockchain is like, hey, I don't need to learn the special contracts. So in terms of, because Ethereum has its own language, it's called Solidity. And Solidity looks a little bit different. So you cannot doing like full, do we have a simple? You see, this is like looking a little bit different than like our Rust code, and you get a lot of more insights to that. If you're coming from Rust, you can use also C or C++ to write in your smart contracts, and you don't need to use Solidity for that. Yeah. And that's the short first steps into blockchain, and also what it can be.
I'm wondering, and this is like a little sidestep on the topic, what is Web3 in that context?
Web3, mostly what people thinking about it is like, okay, Web3 is, hey, we want to build a new web. And as you see, we could really act autonomously on a chain, because it's decentralized typically. So not everything is running on my blockchain. I have one node. It's like different nodes of a world. We have a decentralized system. The network doesn't have a really centralized owner. And now we come into the topic, okay, how can I speak to all these programs that are deployed? Yeah, we're using a library and talking to that. And we need to trust each of them. And how we can trust each of them? Yeah, because we probably see how many transactions they made. it's visible, and probably we have also more advanced concept in terms of, hey, we're using crypto primitives under the hood all the time, and we can do a lot of more stuff automatic. So in terms of, I can check who did the transaction. I want to have I want to do a transaction between Alice and Bob, for example, a finance transaction. And now I want to have a trust holder between that, so that I don't need to trust Bob directly. Someone will keep for us the money and send them Bob afterwards if he give us the benefit, what we wanted, the service. So for that, you can make a program out of it and having these contract and checking it programmatically.
So I just keep getting back to the insecure email sending where I cannot verify the senders oftentimes. Would that be something I could like solve as a contract and as a smart transaction somehow on the blockchain?
Yeah, this can be on when we're talking about identities or when we're talking about systems. So this is like
or like thinking in a way of like using a GPG key to sign an email. This was always like it was dependent on the central servers, and then each side needed to have it, and it was super complicated in my opinion. So like trying to solve that angle. And the second thought I had was we do have like a centralized DNS infrastructure, even though it's distributed. It's controlled by different parties. And I've seen that there are sort of .eth domains, something like that. I think the idea is also have sort of a distributed different DNS system, right?
Yeah, this is the benefit. The ENS is mostly that I easily can find, because the problem is like, who can remember this ID? In Ethereum, it's written in hex, so you cannot remember. That's ENS is mostly for, hey, I want to link to my public key and I can use it to cross over systems, because the name is more simpler to remember instead of having like the public key ID. So
yes, similar to IPv6, you can't remember that.
Yeah,
IPv4 maybe. Okay, yeah, that makes sense. Thanks.
And when we are looking in terms of the topic about identities and who I can trust, as we saw already in the chain, everything is in a transaction, everything is traceable in some way, because it's in a public chain, it's not written in public, multiple people control it. And then we're coming into the topic about decentralized identity systems. So that means like not Google is controlling your identity, you can control your own identity by yourself. For example, your identity is living on a blockchain. It can live in Ethereum, and you can do then key rotation on it also, because it's only the identifier from your blockchain ID. But there's a document it called document where
theoretically
you can
revoke my identity, if I understand it correctly.
Yeah.
If someone does like abuse, or if something happens, I can say, hey, I'm kind of dead now. I'm revoking the key.
Yeah. It's more like an advanced key management system. And the good part of this is everything is on-chain and it's immutable. So that's also the reason why you should not store everything on a blockchain, because you need to remember you can't delete it. But identities is a good place for living on a chain, mostly on a blockchain, because you don't want that it can be tampered. It should be only be the owner of one. So it shouldn't be like multiple owners. We need to clearly identify it. And we can see then also the transaction log, because it's possible, of course, in every chain to go backwards to each history and checking who was the owner of this document.
Okay, so it's like a Git history, sort of.
Yeah.
I had another question, and I'm sorry for so many questions. Storage and ops and things like that. So like the blockchain is in like a software application or a stack running somewhere. What is the backend? What do I need to back up? What do I need to monitor or observe from an ops perspective?
That's the truly part of it. So this is also a topic that we had on another chain, not on Solana. For Solana, I have not so many experience running it in that we running our own validators, but I was in some projects involved where we running our private Ethereum networks by ourselves about different companies also. And because it's a ledger, it's distributed, everyone gets the same ledger. So for example, your node is failing currently. You will spin up and all the transactions go back to your ledger. You need to sync back again so that you get the latest block and then you can participate again on that. So, and the data is not so big, I would say. I think on the Ethereum mainnet, we are currently under 1 terabyte. So it's living now for 3 or 5 years. And monitoring is like another topic a little bit. So because there are different topics, we monitoring them also with Prometheus. And there are also services for you. So for example, when you're looking, I don't want to host myself, I want only to get the data fast. So there's, for Ethereum, there's currently Infura, who which is a development suite, and I can use their high availability Ethereum APIs so that I can get faster feedback of that instead of processing directly on the Ethereum mainnet. So this has also benefit. And you can also, you have different types of nodes, I would say, or servers. So you can have like, I want to write on the chain with my transaction, or I want only to read the ledger all the time so that I can get all the information fast.
Okay, but this is using the central gateway.
Yeah, this would be using now a centralized service for that. They keep care of that. But you can spin up your own node, but then you need to keep care of the data and of the speed and all the stuff.
Yeah, I was like coming from my self-hosted head, thinking of if I want to run that on my systems or on my DMZ or something, I need to take care about storage, backup, monitoring, automation, whatever comes to mind. If I, next question, next thought, if I want to develop on a blockchain, what is the best environment to integrate in CI/CD?
Typically what we do at Spherity is like we're having small private test networks. So to having faster transaction feeds than the test nets. So the problem is there's not one blockchain. So it really depends on in which ecosystem you are currently living. So for example, I think when we're talking about Zolana, I would say start with a DevNet. So you don't need to host your own nodes. You can participate to that if you want to, but if you want to program, so like if you are only interested to write your program, like we did now with the Hello World and doing all the Rust stuff here and shipping these lines of code, use existing nodes or starting with your local ones. In CID, I didn't test it yet, so we have only few projects with Zolana right now. And for Ethereum, we're running mostly also the public networks in some ways. So there are also, Ethereum has, let me check.
Yeah, so it kind of makes sense to like get your private get your key pair or your public key and inject the authorization into your CI/CD pipelines then.
Yeah, if you want to deploy it in that way, the problem is like on real systems on the mainnet, is that you need to pay transaction for that, and you shouldn't change it so often. And you need to keep care of that, but there are different networks. So we have how can I change it? Here we see it. Cool. So for Ethereum, we have the mainnet and the mainnet in China, of course, with a big firewall. And then we have different test networks, and they have different settings. So some of them, the transaction speed is a little bit faster. This is also in terms of developer support, which are the bleeding edge features or not. So, and if I want really to start on that, start with ring B and go for it mostly. So when you want to start with Ethereum, if you want to start with Solana, I would recommend going to the mainnet and using the DevNet on that.
Okay, and to really like understand what's going on in the background, it makes sense to either check out the local installation or Gitpod, like getting an idea what's going on in the background and not.
Yeah, because it's a little bit simpler locally to see how many transactions are passed instead of a DevNet. And then you can easier see and you can restart from scratch again. That's why I really like it. You can also do this with Ethereum, but it's a little more effort. So for that, we have, I don't know, the tool was called Ganache, I think.
Now I'm hungry again. Thanks.
Ganache is a local tool for one-click blockchain, and there you can deploy Ethereum and doing all. And here you see this address is a little bit different to our Solana address, but this is only a public key encoded in hex. That's fine. And base 58. Yeah. But yeah, so there are different types of using which tool and which blockchain. The ecosystem is also different. So, and also how to program the smart contracts is also different, mostly.
Yeah, I think it's great to have like one way to get going, because I feel like blockchain is similar to Kubernetes. I saw the entire ecosystem or entire community and was like, I have no idea how to get started. I need to understand everything. So I really think it's great how you showed what is possible and how to use the tools and how to like start the components, deploy the programs. And yeah, if you then want to develop it or test it, use the SaaS offering or the cloud, and don't try to self-host everything, especially when you're collaborating with teams across continents, probably.
Yeah, it depends also a little bit on your learning curve. So I would start now with the newer chains instead of the old ones, because the old ones are a little bit more, you find a lot of outdated resource on that. And Zolana, Polkadot have a lot of more better developer experience, I would say. It's not so abstract, and this is what I really like on that. So, and the examples are more clear sometimes.
Yeah, there are probably some. There are many people out there on Twitter and in the community who can help and engage with. I've been following Nada David, who was, I think, at AWS and changed into blockchain a while ago. And I always was like, I want to learn how this works, but I have no idea. And it's, for me, learning is learning by example, learning by getting someone like you showing me what is possible. I don't learn so much in a Twitter space or with following a video course. So I like hands-on.
Yeah, but you should really check out from Nada the tutorials. They are really good. So for first time developing, and also what he wrote also an excellent blog post about what is Web3 mostly. And what it's not. So it's quite interesting. And he wrote there, this is a really good resource. So you should check out his DevTO account, where he has all his blog posts mostly. And here's also a full guide for doing something on Ethereum. I think not on Solana yet. Or checking YouTube videos. This is also sometimes a good idea.
Oh, there's the complete guide to full stack Solana development with React, Angular, Rust, and Phantom. That sounds like my next weekend project. No, but yeah, there is building. I will share that on social. Yeah, and there's also defining the web3 stack. Interesting. It's great that there are so many free learning resources out there.
Yeah, there are a lot of them. Mostly it's finding the right ones, what's fitting for you. That's the hardest part in the end.
Yeah, I have a mini thread on Twitter where I can link to resources. If I want to start reading a book, is there like a recommendation you have?
Yeah, mastering. If you want to start really understanding the concept, so the best book, people would say it's outdated, but it's like bringing you the basics. It's called Mastering Ethereum. So it gives you a really good start into the blockchain world, because he's also talking about DLTs and that not existing everything from the world. I can send you the link. I think also the resource, you can read it for free on his GitHub profile, I think.
Probably. I think he's a great resource, or he's creating great resources, and he knows what he's talking about because he's a developer as well.
Yeah. So they're written in ASCII. If you don't finding the formatting good, you probably can read it also there. But it's like a good resource. I think there are also some other on that. I would not look like into the topics of, as I said, NFTs and all the stuff. We can make a separate session on that. So because mostly when we're talking about NFTs and own coins, these are only specialized smart contracts in the end, nothing more. So yeah. But more interesting for storage and for decentralized stuff is also probably that we need to look into IPFS. So because it's like an interesting system.
Yeah, next month we take a break from I don't know where to put in blockchain. Is it DevSecOps? Somewhere in between. So Anna is joined Aqua Security, and she wants to join us and dive into Trivy, Starboard, Cube Hunter, and other things. And I said, okay, then let's dive into a little bit about security, which is the second Tuesday of March, should be March 8th. And yeah, in April, we can see how far our journey has gone, or if there's something else to talk about. I think May will be rather, May is KubeCon later on. So we might be doing something around Kubernetes or cloud native stuff. But let's see. Are there any, I've been talking all the time. Are there any more questions, or is everyone brain flooded?
Quick introduction.
Yeah.
Or is everyone just fixing the Git port?
Everyone is now deploying Rust again. But you need to remember that we deployed no Rust until under 30 minutes. So we have an improvement here.
Yeah, we're just using pre-builds and Git port works.
Yeah. Let's make a section out of it. Pre-builds and Git port and Rust. And then I see us that we debugged something for 3 hours.
Yeah, the problem was just we didn't understand how the Rust module system works, and the getting started guide was pretty clear about it, I think, but we didn't want to follow it. So it was just like we have our own thoughts, and we don't want to read the documentation problem. But in the end, it was fun. It somehow worked.
Yeah.
Okay. Yeah, maybe we can do a dev section on. I could do that potentially, like instrumenting applications with metrics and maybe OpenTelemetry. And I'm not sure if it will be Rust or if it will be Python or Java. I'm not good at Java, but worth a try. So I will be working on content in the next weeks around this topic. And this could be something which we could also do a hands-on and trying it out together. But let's see about it. Next month will be security, and then yeah, open to suggestions. And obviously we talked about a little bit about overtime again. I will upload the recording later to YouTube. Yeah, and until then, I wish everyone a great rest of your day. Stay healthy, stay curious, and we will meet each other again on March the 8th. Bye.
Yes.
Bye.
Bye.